Hello dear fans. How does the current strength in the resistor change? The current strength in a resistive element, as a rule, is considered in the context of considering Ohm's law for a section of a circuit, which explains the patterns of changes in the current strength in a resistive element. Instructions. Step 1. Open your grade 8 physics textbook to the electrical phenomena chapter. This chapter deals in particular with electrical phenomena in an electrical circuit. As you know, an electric current is a directed movement of free charges in a circuit. These charges are usually electrons. Accordingly, the strength of the electric current is defined as the number of charges passing through the cross-section of the conductor per unit of time. Thus, the more charges flow in the conductor, the greater the current will be. And also, the greater the speed of movement of the charges, the greater the current in the resistor will be. Step 2. Remember what is meant by a resistor. In this case, a resistor should be understood as any conductor or element of an electrical circuit that has an active resistive resistance. Now it is important to ask the question of how a change in the resistance value acts on the value of the current strength and what it depends on. The essence of the phenomenon of resistance lies in the fact that the atoms of the resistor substance form a kind of barrier for the passage of electric charges. The higher the resistance of a substance, the more densely the atoms are located in the lattice of the resistive substance. This pattern explains Ohm's law for a section of the chain. As you know, Ohm's law for a section of the circuit sounds as follows. The current strength in the section of the circuit is directly proportional to the voltage in the section and inversely proportional to the resistance of the section of the circuit itself. Step 3. Draw on a piece of paper a graph of the dependence of the current strength on the voltage across the resistor, as well as on its resistance, based on Ohm's law. You will get a graph of hyperbola in the first case and a graph of a straight line in the second case. Thus, the greater the voltage across the resistor and the lower the resistance, the greater the current will be. Moreover, the dependence on resistance is brighter here, because it has the form of a hyperbole. Step 4. Note that the resistance of the resistor also changes as its temperature changes. If you heat the resistive element and observe the change in current strength, you can see how the current decreases with increasing temperature. This pattern is explained by the fact that with increasing temperature, the vibrations of atoms in the nodes of the crystal lattice of the resistor increase, thus reducing the free space for the passage of charged particles. Another reason that decreases the current strength in this case is the fact that with an increase in the temperature of the substance, the chaotic movement of particles, including charged ones, increases. Thus, the movement of free particles in the resistor becomes more chaotic than directional, which affects the decrease in the current strength. Thanks for watching.